Okay, welcome to the episode 28 of Learning Healthcare Interoperability with me, Diego Kaminker, and Ed Hammond. Ed Hammond cannot be here today, so I'm alone, but I'm not alone with two guests. That's very lucky for you because I'm very bored alone. And for me, we are recording from the McNamara Center in Minneapolis during DevDays, an event that we put together with Filey and HL7 International. With me, we have the first repeating guest in the history of the podcast, which is Dan Vreeman,
Oh, what an
our
honor.
Chief Standards Development Officer and AI Officer. It's the second time he's with us.
It's true.
So you are the first, like Messi yesterday.
Yeah.
Was the
Wow.
So
The
you are
repeat.
now-
You got to get to 6 World Cups, right?
Yes, you are the first in two episodes.
Terrific. Well, it's great to
We
be
are
here.
honored.
Thank you so much.
And that's the important guest now. We are with Imran Qureshi. He is Chief AI and Technology Officer for b.well Connected Health. Okay?
Yeah.
So now we have an episode devoted to AI. You may hear some noises because we are around a lot of people. That's lucky for us. Very nice event. Let's start with the questions. I'm old, so I have to read the questions sometimes.
No problem.
Okay.
So the first one, I will do both questions for both of you. You may fast.
I like what he said.
Yeah. So the first one is, if a model can read a fax, a PDF or CDA, and a clinician free text, and the model can pull out the meds and problems, do we still need work on structured exchange? Does AI make our standards less necessary or more? And I will start with him, then we will know the truth from you.
Yeah, I think this will be a good interplay. I think maybe what I would start with is, at a very high level, standards actually are a way of expressing the agreement between people about how they want their systems to behave. And so even when AI is amazing at processing lots and lots of kinds of data, we will still want and need standards that express how humans want those systems to behave and interact with each other. So at a very high level, standards aren't going away. At a more precise level, there is a question around the ways in which structured data plays or will continue to play a role in an evolving AI era. But what I would say is, today, and the way in which AIs get their power is by access to complete, accurate data about the kinds of questions and interactions that we want them to have. And the best techniques we have today for getting data to AIs are with standards like FHIR, as well as getting those responses from the AI back into the systems of care that humans, patients, clinicians, their families are interacting with. And so in some sense, the ways in which AI is lowering the barrier to getting those systems to evolve and improve care are happening and growing throughout the ecosystem is actually raising the need for and the importance of data standards to fuel that kind of innovation. And I think for quite a while, even though they are getting better at interpreting data in different formats and even producing data in standards, which is their sort of grounding in our sort of shared reality, the machine reality and the human medical reality of what's happening, I think data standards are going to continue to be super important.
And now
Yeah, I think I agree with what Dan is saying. I think the question we always have to ask is, it's not about what you can do, but what you should do, right? So I can certainly take a power drill and I can hammer a nail into the wall. Like, it will work, right? But it's not the right thing to do. A power drill is designed for something very different than putting a nail in the thing. So we have to think about, what are LLMs really designed for? So the LLMs are, at the basis, very simple machines. They're just predicting the next word. They're looking at all the words that came before, and they're predicting the next word. And that is good for lots of things. But actually, I think what you'll see is the move is actually, we use LLMs with English because English is where things are. But there's no reason that LLMs have to be limited to English. They'll actually start to evolve into getting more compressed data. And I'll give you some examples, right? So I demonstrated that this morning too. If you take your PDF of your health data and you put it into the LLM, it will figure out some things. Like if you ask for it, what is this one reading, it will be able to find it. But if you ask it the question, how's my blood pressure doing over the past 2 years, you'll realize that it gets confused there. And it will actually start to just pull out individual readings and start to talk to you about individual readings when your question was more, how is my blood pressure doing over there? And that is represented much better in other formats than English. English is not a very good way to represent a lot of data, right? And so what we've found is that when you create other formats that are based on standards like FHIR, and you can represent the data like that, the LLMs are then able to understand that your blood pressure has gone up 10% over the past 2 years, and then they can reason on it. So it's going back to the example, like we should use the LLMs for what they're really good at, which they're awesome at, and we should not use it to hammer a nail in the wall. There are other tools that are much better, like standards and other formats to handling that.
Can I also answer?
Yeah, you are the host. You can.
And maybe you can correct me, but we also need to tag things, create the metadata. This belongs to this patient and was created this day, and
Sets
it's
the context.
here or there, and we want to get that. And that's also our mission, to get all the information together,
Absolutely.
because if not, AI cannot get it.
They cannot get it.
You cannot put AI on nothing. You need to have all the information together.
Yes.
And that's also our mission.
Yeah. I think it goes back to like using the right tool for the job. So I think, is the LLM the right tool to go find different data elements and link them together? Not really, right? That's not what a next word prediction does. We have already pretty good tools that do that. So our goal isn't to throw away our whole toolbox and just have the power drill as a tool. It is a new tool that we add to our toolbox.
Okay, my second question is, FHIR was built for deterministic system-to-system exchange, and AI is probabilistic. Does FHIR itself need to evolve to be AI native? And what would that even look like in terms of provenance, confidence, and uncertainty as a first-class citizen?
Yeah. So that's an interesting question. And I think there are a few dimensions in which FHIR does need to evolve over time as the ways that AI integrates with clinical information systems also change. But I'll start maybe at part of, I think the heart of your question is at representing where information comes from and how that information was derived and how it's used. And there is sometimes uncertainty in that information, but that it didn't just come with AI. There's uncertainty about information in different sources. There was uncertainty before AI. What we haven't really done much of in the industry is represent in a consistent or standardized way data lineage. Inside systems, there's pretty robust ways that's done, but we haven't really had use cases where we had to share and exchange and track across systems that lineage, right? And in AI, that is important because we will want to know in a very direct way what was involved in the training of various models, what was the context of a particular prompt at a time, and then the response of that AI. And so we will want these ideas around consent for use in certain purposes, such as model training, tracked in a computable way, in a very precise way that we can understand its lineage, as well as...
We did before consent for using your data for research. Now we can also ask, can we use your data for...
Exactly. And it will be interesting to see how this plays out politically, but there are certainly conversations being had in some proposed bills that may require it in certain cases where the disclosure of AI and the explicit consent for that as well. So we'll see where that goes, but I think there are many reasons why that traceability into the information AI consumes and produces will be important, and we want to have that as part of our standards representation.
Run?
So as a data scientist, I would first say there is nothing deterministic to begin with. And certainly not in healthcare.
Only that.
It's all probabilistic. And in healthcare, it's true. Even when you tell someone they have diabetes, it's not a deterministic evaluation, right? So a doctor can look at someone's A1C and they can say this person has diabetes.
So I may not be fat?
But I think...
That's new.
Yeah. But the other example I'd bring up is, so quantum mechanics, right? So quantum mechanics tells us that really, even at the base level, everything is probabilistic. Then you ask the question, okay, if an electron can be in multiple places at a time, why are you not in multiple places at a time? And the answer is the individual electrons and atoms are probabilistic, but when you combine them all together, the more you combine, the more the deterministic and less probabilistic a system is. So I think we have to really start to think about lineage as not this single line that gets drawn, that a data is entered accurately here and then passed accurately here and then passed accurately there. I actually think there's an opportunity now to say data is actually represented in many different ways and none of them is actually deterministic. But when we combine them, you start to get it. So I'll give you an example, right? So we can get records from two different places where one record says this patient went to the emergency room and the other record says they died 5 days ago. Which one's right? We don't know. Did they go to the ER today or did they die 5 days ago? But now if we start to get more data as to what treatment was given to them, did they file a claim, did they pick up medication from pharmacy, that data together can tell us, yeah, they're probably not dead because they wouldn't be going to the pharmacy. And they would. So I think where really the opportunity of starting to think of lineage as not the single line and combining it, actually what it does is it allows things to become less and less probabilistic by combining it, just like quantum mechanics takes all these different things and combines them together. And that I think is a real opportunity. And I think we have to admit the fact that nothing in healthcare is actually deterministic, but we can understand the probabilities and by combining data, we can actually start to get to more accuracy.
Very interesting. My question is whether systems are prepared to tag some information as created by AI or as compiled by AI and which engine, and if they can transmit that information.
But why does that matter, right? So like today, when you go and you do a lab test, you connect to a machine and the machine says,
well, we have an audit of which machine created, but in fact, even if the device is not certain 100% about the test, it will tell us. Like for instance, in microbiology, we have some instruments that will tell, this is here calling, but not sure. 90%.
But that's the point, is like we should not treat AI any differently than any other measurement device you have, right? So just the same rules that we apply to a machine that measures your heart rate, a machine that measures your A1C, we should just apply the same rules. A1C is a measurement in some way. We should have the same audit trails and we should have the same level of uncertainty being passed through. So that I think is a new element that's going to come in, which is that we assume things are deterministic. But if nothing is deterministic, then along with the data, we have to pass a measure of the uncertainty of that data.
Very interesting.
And that combines together like quantum mechanics, where you can combine the uncertainty together to really start to get a sense of how certain are we about this combined data.
Yeah, we've started to explore a little bit the patterns that you might use for that, including being able to link or attach or build pointers to specific kinds of evidence that might support an assertion of some kind or an outcome of some kind. And I think you're right. I think the idea to which we can build the case around, the context around the information will also help us not sort of draw the line, what's our probability threshold, but more understand how to use it, what is it good for, and the potential use of that information in different contexts may require different levels of sort of evidence about its certainty.
I think that's a really important point, because there are going to be some use cases where we're trying to say, should this give this person this medication where the level of accuracy needs to be high? On the other hand, if we're trying to say, should this person have this lifestyle change, the accuracy is kind of low, because if we told them to eat better and it actually didn't help them, we didn't harm them either.
Pretty sure. Okay, next question for both. Data quality is the quiet bottleneck. If AI is only as good as the data it's grounded in, is the real frontier, not models at all, but conformance, validation, and quality frameworks. And which quality framework?
I think your question is on point. That is the degree to which the data going into the model is of high quality and certainty always influences the ability for that model to help in some way, to provide good answers, to provide reliable answers, and so forth. And healthcare as an industry does have, I would say, quite reasonable expectations around quality and a focus on quality and quality information. And yet also, because it's such an information intensive industry, there are lots of areas where the burden of producing that high quality information is maybe not placed along with the right incentives to do it and at the right point of time. So I think the idea of being wowed by the power of AI has mesmerized a lot of magical thinking about what it can do. And so the natural tendency is to throw lots of data at it without necessarily understanding the implications of what happens when those kinds of data inputs aren't so great. And so we backtrack. It wasn't like we didn't know about the importance of data quality before, but this is heightening our awareness of that and also, frankly, giving us some tools for assessing it at a higher level than we had before. So to answer kind of the first part, I think of ever more importance is good quality data. AI needs it. It can also help us in our evaluation of data to find places where it could be improved and traced back. The question of which frameworks or how we do that, I think that's still an open question. Certainly, one of the things within the HL7 community we're really excited about is the work of the PICI framework, the Patient Information Quality Improvement Initiative. And I think that's a great starting point. I'm really excited to see where that conversation goes. But certainly having consistent ways of assessing it will also help us track back and understand if we're improving it over time.
Yeah, so I think one of the interesting phenomena that's happening is that the LLMs are now basing more and more of their answers on Reddit. So this is a fact that's been shown, and I think none of us would agree that Reddit is accurate by itself, right? So I think data quality is definitely the number one thing, but I think it's a cycle because I don't think we can expect that the entry of data will get better much, right? Because there are incentives like Dan was mentioning, doctors in a hurry, there are all kinds of systems in place. So the idea that all the systems out there will suddenly get better and everyone's going to pay more attention, I think we have to give up on that also. I think what we need is a refinery model, which is the oil in the ground everywhere is not going to get clean. The water everywhere is not suddenly going to get clean. We have these refineries that we can go through and clean them. And that's what we built at b.well, that we can show that we can take the data that's out there, which sort of grades F on some of the PICI measurements, that we can take it to A in the refinery model. So I think that's really going to be where the power is. I don't think we can expect that somehow data quality everywhere will get better. I think it's going to be that we have these refineries come online that can clean the data before it goes into AI.
Or maybe even this same refinery can feed back, maybe in an evolutionary way, to maybe improve the quality. If we discover that the same problem is in everywhere, we can just improve it also.
Yeah, and for example, we've built routines for like how we understand labs that come in different codes. Once we built them, we can run them on millions and millions of patient records, right? Because we've now built them. I think you're going to start to see the rise of these refineries like ours that are essentially doing the same cleaning, and not that each place is going to get clean.
Okay, let's go to the next one. Sure. Was making FHIR in a human plus machine friendly format and also licensing it as Creative Commons the most consequential AI decision HL7 ever made? What does that imply for standards that are licensed or closed?
I'm probably a little bit biased in my answer on this question, or maybe I have an inside perspective, but but I've been a believer my whole career that, the point of standards is to get them used, and they actually increase in value the more people that use them. And so that has, in part, your question had two parts here. One is a machine computability aspect, and then the second is the licensing. And on both counts, we want machines to be able to understand the specifications, both data coming into it as well as helping us transform data into them. And lowering the barrier to do that implies a particular licensing model as well as the sort of practical techniques. And I think looking around what's happened at this conference, you see the fruits of that, where you have an open community and you have an openly available standard. People have built lots and lots of amazing things on top of that platform. So in that way, I think it was extremely consequential. And the fact that all of the major models today were trained on and know about FHIR because it was made available in this way.
But also our other technology.
The other technologies, all of the open source code that has been built to implement that is accessible in that way. So certainly hugely consequential. And so I think from a standards development mindset, if you're still thinking that your product is the specification and I should try to monetize and sell that and protect that, I think you're putting up barriers to this kind of ecosystem development. And if, as is the case in some other perspectives today that are saying this is protected and I don't want LLMs to use it and don't put it into the,
And we
to the
saw that.
model.
We saw some.
I think you're putting artificial barriers that are actually hindering the end goal that you have in mind. In addition, we'll watch the legal front evolve in terms of what sort of fair use and the way in which standards reference and regulation, those kinds of factors play out in terms of how standards are used. But I think fundamentally, we want machines to be able to interact with and understand standards-based data, and that licensing decision is part of it, as well as the design of the specification itself.
Yeah, I think 100% agree with Dan. I think I'd present a counterexample, which is CPT codes. Right. So if you go ask, if you take your explanation of benefits and you upload it into any LLM, you'll actually be able to explain a bunch of things except for CPT codes, right? Because CPT codes are licensed and not public. So as a result, it can't figure out what the CPT code means. And so it doesn't know what this procedure is now. And so I think it's really, to Dan's point.
So if we are going, can we go again? Yeah. If a person reads the explanation of benefits that belongs to himself, he cannot know what happened.
Because CPT codes are owned by the
Yep.
So I think it's just I think you have to understand what business you're in, right? I think those are old business models. The business models of restricting data and saying no one can get my data and I think health systems are doing that now. Like you see,
the same applies to health systems.
Yeah, because health systems are saying, I don't want my data to be used for AI. You're like, what use for AI are you thinking? We don't know. If you don't know, why are you restricting things you don't know, right? And I think exactly, like I believe let's try it out. When we see issues, then we can address them. Let's not proactively hold things back in a locked drawer and wait for something to get figured out.
Can we continue, or are you tired?
I'm not tired.
This is fun.
Okay, I have more questions.
Okay.
Next one. Let's talk about terminology. If an LLM can guess what a free text term probably means, do we still need strict terminology bindings like snow, meadow, line? What is more dangerous, a wrong guess or
yeah, so there's some good questions there. I think maybe to start with some of in the same way that structure standards like FHIR represent an agreement about human understanding and desire for how machines should interact, those standard terminologies represent a shared mental model among humans, experts in domain areas about the reality of biomedicine and what constitutes something that is the same or different, and assigning in a sort of more precise way a label that groups the reality into those buckets. And so in that sense, those standard terminologies are really important groundings for AI in the sort of biomedical reality. It's a way to express that to the LLM in a slightly more precise way than if it had to figure it out de novo. So super important. Is it also true that AI can help us transform the various very creative expressions of human language into candidates for, and in some times very accurate candidates for coding in those ways? Yes, that also is true. And in some sense, I anticipate that AI will help us actually standardize more things that wasn't possible when it was only human effort that was doing it before. So that's kind of how I think about it. It's certainly that level of structure is an important grounding. And there are a lot of cases where minute details of language expression make huge differences in the healthcare context. Lots and lots of medications or conditions vary by a single character difference between them. And so that level of precision is part of the way medicine works. But this sort of systematic approach to developing and using standard codes is, I think, going to persist as an important thing at the same time that AI is going to be very powerful in helping us understand and use it.
And as a follow-up, I have, does clinical decision support exist without precise code?
it can in levels of uncertainty, right? And so where that sort of threshold for is this something we are going to act on and move on is one of those dials that it's certainly true that a great way to frustrate clinicians and get them to ignore your computer system is to routinely prompt them with things that they look at and say that's irrelevant. And so in the same way, any decision support system has to be tuned to be as precise as possible. And clinicians have a pretty high threshold for their sensitivity around those kinds of suggestions. And so I think it's a dynamic that we have to adjust to.
Yes, I agree. The terminology is important. I think if you go back to how LLMs work, they're linear, predict the next word kind of way of doing it, right? So terminologies capture hierarchy in a different structure, right? Like this ICD-10 code is related to this ICD-10 code. This medication category, ATC, is related to these. So those hierarchical representations are clearly important to maintain. However, I think we don't have to be so strict anymore, right? And going back to our discussion earlier, like we can start to reason in uncertainty. So for example, when we get a prescription, we get the prescription from the doctor, we also get the payment from the payer, and we also get the fill from the pharmacy, and codes don't agree, right? That the doctor may have written a prescription for a brand, the pharmacy, filled generics, the doctor said to give 20 tablets, the pharmacy only had 10, right? So I think
that's reality.
Yeah. And so I think we've been obsessed with solving these things with accuracy. And I think we failed in healthcare for decades at it, right? I don't think we're any closer than we were 20 years ago in this. I think what what we get now is really accept the fact that this will never be fixed at the source, but we can reason on uncertainty and combine uncertainties together, right? So if the doctor's prescription is saying they should be on this medication, but the pharmacy is saying they're on completely different medication, that's a problem, right? But if the doctor's prescription is saying they should be on this brand and the pharmacy is there on this generic, through terminologies, we can say they're the same thing. So we can start to reason on uncertainty and really push uncertainty all the way through the system rather than assume that we'll be able to get to 100% certainty at the source. And that's why I think terminology, we don't have to be that strict anymore. Like we don't have to get the IC10 exactly right. We don't have to get the RX norm exactly right.
When an AI agent misreads a chart and acts on it, who is accountable? And does our interoperability infrastructure even have a way to catch them?
Yeah, I think we certainly have had a lot of experience already with this idea that clinicians choose to use lots of different tools. And when they choose to use those tools, they accept the responsibility for incorporating that in a certain way within their judgment. And I think that paradigm of liability and accountability still holds for the most part in the context of AI as well. It is information that can be used and processed, and ultimately when clinical recommendations are made based on it, it does fit with this sort of paradigm of licensure and accountability that goes with that. I think we will start to see different models of institutional sort of agreements about accountability and between developers of models and healthcare institutions, because things are co-evolving in a way that maybe didn't happen as much before with other kinds of technology or other kinds of devices, where it's more of like I'm just going to buy this and here I'm going to bring it into my system. There's definitely a fair bit of co-development going on, and so that may change it. But I think the question does also point back to a little bit about what we were talking earlier, is that we do also we needed it before, but we need ways to understand what information was available and used at this time to make these decisions, to take these actions. And so understanding what the AI produced and what the human reviewed and what they acted on based on it, we will need traceability into that sort of landscape. But fundamentally, AI is a tool that's incorporated into a process of delivering care that people ultimately accept responsibility for.
Right?
So finally, we found something we disagree on. So I think right now we're doing this.
We're disagreeing from the beginning, which I love.
I think we're playing this BS game right now, which is like AI is going to come up with all these insights, but the doctor is still responsible. I think that's a BS game, right? Like if a lab gives an A1C value and the doctor takes an action on it, the doctor is not responsible for that solely, right? the lab is responsible for not calculating A1C correctly. So I think AI is going to have to take responsibility. I think you're going to start to see malpractice insurance tied to AI. And it's going to be this shared accountability where the clinicians have to trust what the AI is telling them at the sort of with the caveats the AI is telling them, and AI has to take accountability for that. I think the other thing is, I think we talk a lot about what if AI gets it wrong. I think what we don't talk enough about is what if a doctor doesn't look at AI? So I think you're going to start to see malpractice lawsuits come in the other ways, like if the doctor had used AI, they would have found this issue. The doctor chose not to use AI, they did not find that issue, so now they're subject to malpractice. So I think you're going to see a lot of malpractice lawsuits kind of driving the adoption of AI through that way, because all our discussion about what if AI gets it wrong, I think we have to ask the question, what if people don't look at AI and AI got it right?
And also, I think I saw last week a lawsuit against the EHR of some action, which was the first.
Was the first?
I think it's just a BS. Like I know doctors and stuff, they're just saying, okay, you have this AI, but you're responsible for everything. That model is not going to exist. That cannot survive that model. I think it has to be shared accountability, like it always is in healthcare. Like if another doctor gives you a referral and they tell you something, you as a doctor rely on it, right? So now, of course, you do some checks, but you're not responsible for reading everything again and redoing the previous doctor's job. So there is going to have to be some accountability. I do think that we're going to get to malpractice insurance for AI. I think we have to treat AI more as a type of practitioner than it is just a data source.
Nice. I don't have more questions. I will add my question for you both. Then you can ask a question to each other. So my question for both of you is, long term, what do you see in the next 6 months?
Long
6 months is long term
6
now?
months is AI.
Yeah, in the next one. Yeah, I think so in that sort of time horizon, certainly the sophistication of agent orchestration is going to improve. I think we've begun to tip into that a little bit thus far, but for the most part, we think of a single sort of AI interacting, say, with a data source, and the sort of paradigm for how agents call tools and agents relate to other agents and interact with each other is moving so quickly. And because the ability to create and tune them and scale them and deploy them is also raising. That, I think, is the area that I'm actually most excited about seeing, is the interplay between agents and their orchestration.
I think I'll give you a few, right? So I think one is today AI is largely used for answering a question. So I would say in many cases it's a glorified Google search, right? I think it's moving from that to achieving goals, right? We call them loops, whatever we call them. It's like you can give it a goal and then you can give it constraints on how to test if it's met that goal, and it will just keep running and trying things until it figures it out. So we see that in software development now, where you can give it a goal and it'll keep running and it'll keep writing code, it'll keep writing unit tests, and we'll check that and all that stuff, right? Yep. So we think we move from the world of asking a question and saying that's the end of it, is to say, here's a goal and keep working on it until you get there. So I think that's going to be one. The other one's going to be, I think, the return of domain expertise through skills. Because the idea that one general purpose model can answer different types of questions, I think is wrong. Like one doctor can't answer different questions because a doctor specializes in an area. So I think you're going to start to see these agent skills come in, where domain experts are creating skills and the models are choosing the right skills to answer different questions. It isn't one model that's be able to answer all the questions, because even if you look at different specialties, the same things mean different things in different specialties, right? So I think you're going to see that. I think third is you're going to really see that I think we're seeing that the ROI of AI on the health system side is really not there. So if you look at AI scribes, you can read lots of studies. Doctors are not seeing any more patients as a result of AI scribes. It is just like a glorified autocomplete or spell checker or something like that. So I think what you're going to see is really that AI isn't materially going to give you ROI on existing workflows. Because existing workflows, it's the typewriter we use, by the way, is designed to make us slow. Because the reason the keys are arranged that way is because the old typewriters would jam, and so they came up with something to slow us down. So the workflows are designed for the constraints that they were. I think what you're going to see is really this emergence of new workflows that are going to be optimized for AI. So for example, like if I want to get my lab results, I can just go to a lab and get my results. I don't need to go to the doctor and have them order labs and then do labs and bring the lab test back to the doctor for them to tell me that my LDL is high. So these new workflows will start to emerge with AI that I think we're really going to see the ROI. You're not going to see the ROI with just trying to speed up our existing workload.
Very
So
interesting.
I gave you 3 instead of
Now
1.
you are asking a question to him, and then you're asking a question.
Perfect. So Imran, you are certainly a champion and a builder on top of standards, a believer in what they've done. My question is maybe one thing you think as a standards development organization we should keep doing, keep advancing on, and one thing maybe we should stop doing or do less of. Do you have thoughts on things that have been helpful to you and things that maybe you'd say, it's not ain't gonna work anymore?
So I think that I would say we have to keep working on standards. I think we talked about today that these standards are really important for AI. AI is not a replacement for them. I think what I wouldn't say stop doing, what I would say start doing is really start to capture uncertainty in our standards, right? We've had this discussion. I think we assume that data is 100% correct, and that's never been true in healthcare. We just said it, right?
Which is the 100%.
Yeah, we just assumed it. We just,
Pass it
and
on.
so I think what we have to really start to do in standard is how do we capture uncertainty and pass it along so that systems downstream can combine that from different sources to then get to a better certainty. And that I think is something we should really think about is how do we represent uncertainty as in a standard way that we can pass along and systems can reason on uncertainty rather than assume that everything they see is 100% certain.
And now you have to ask a question to that.
With AI, one of the topics we're talking about is I think the good thing is that we don't have to be as accurate as we had to be before, right? So for example, we had to know the RX norm code exactly. If we got it even 1 digit wrong, to your point, we would be screwed, right? Or if we had NDC code and we mistyped a number, we'd be screwed. I think what AI gives us is the ability to handle things in a fuzzy way, where it can say, yeah, you're off here, but then this thing tells me that you really meant this. And you can try this today, right? Like, you can go ask it a wrong question, and it will basically say, I think you meant to ask this. So how do you think standards evolve in that world where I think fuzziness is now more acceptable? And we don't have to like hammer people on, get the RX norm right, get this thing right. We can say, represent it in however you want. We will be able to reason on it.
So in some sense that relates to, I think, how maybe not quite as much about how the standard itself is built, but in terms of how we expect software to implement and relate to that standard. I think in the case that you were describing, it's not as if we don't need RX norm codes anymore. And certainly the structure around how a code is structured and the attributes or the metadata around that help us figure out what level of uncertainty is acceptable for a particular use case, right? Because there are cases where the action that I want to take based on that information only requires that I know generally what the item is or the product is or even what category it belongs to. And there are other cases where it actually matters a great deal and has to be precise. And so I think building into the way in which our standards are expressed, the ability to have that range of precision and adapting it to the use case, I think is a very valid point. And I think there are some things, the way in which FHIR relates to and makes use of through value sets and bindings and things, those coded elements is a particularly good example of where that sort of flexibility can be built in as well. And we could think about that in the case of authoring profiles, et cetera, as well.
My conclusion is that we are not as certain as before, but it's okay.
But it's okay.
Well, we can still reason on
Gentlemen.
it. We can reason on this.
All right, thank you.